Hello everyone. Today we'll be reviewing question 1 for the ratio test for convergence review sheet. If you have questions about the ratio test itself, there will be another video that you can watch. So here's question 1. Determine whether the following series converges or diverges. And this is our series here. We have the summation when n equals 1 to infinity for this um, quantity right here, which is parentheses n plus 2, close parentheses, times 4 to the power of n, all divided by n factorial. Now, something important to remember with our ratio test is that we are trying to find the limit as n approaches infinity for the quantity with the absolute value of a sub n plus 1 divided by a sub n. So that's what we have right here. Now we first want to identify a sub n and a sub n plus 1. A sub n is just our series itself. We are leaving n alone, and there we go. You see that this here matches this here. Next, we want to find a sub n plus 1. A sub n plus 1 is where we take each n in our series and we add 1 to it. So if we look from our original to what a sub n plus 1 is, we see that we have an n plus 1 in place of n. So we have the quantity of parentheses n plus 1 plus 2, close parentheses, times 4 to the power of n plus 1, all divided by the factorial of n plus 1. So now we can go ahead and set up our thing and solve. So we have the limit as n goes to infinity for the absolute value of a sub n plus 1 divided by a sub n. Now I'm going to substitute in our values that we have specifically for this series, and that is shown here. Notice from our next step that we drop the absolute value bars, and that's because this will all be positive, so there's no need for them anymore. You might notice that it's set up a little differently, in which we have a fraction here and another fraction here. They're being divided by each other. And when we have two fractions being divided by each other, we can take the reciprocal, the bottom fraction, and multiply that. So now we have the limit as n approaches infinity for this quantity here. We can then, after that, we can then do some simplifying and some reducing. So in our next step here, we see that we're taking our n plus 1 plus 2 and we're simplifying that to n plus 3. We have 4 to the power of n plus 1 and we're splitting that into the 4 to the power of n times 4 because that 4 to the power of n plus 1 is essentially this here. We also are simplifying our factorial. When we have factorials, we can remove out terms and then add a factorial to the rest of it because n plus 1 factorial is saying n plus 1 times n times n minus 1 dot 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 until you get to 1. This here is saying the same thing because we have n plus 1 times n factorial, which is then n times n minus 1. So we have simplified that. And then we leave our other one alone. Now we can simplify even more by crossing out our common things. So we have a 4 to the power of n in the denominator here. We have a 4 to the power of n in the numerator here. We have an n factorial in the numerator here. We have a n factorial in the denominator here. So now that leaves us with the limit of this quantity here, in which we can then simplify again and expand out to get this. Now we know with our limit rules that when our power on top is less than our power on the bottom, so if we look at our n, the power here is 1, and we look at our n here, our power here is 2. When that happens, when our top is less than our bottom, our series is going to approach zero because the bottom part is growing much faster than it is growing on the top. So with our ratio test, whenever our number is less than 1, the series is going to converge. Thus, question 1, determine whether the following series converges or diverges. This series converges. Thank you.